Okay, this is the Intermediate Algebra, Chapter 10 Review, Part 1. There will be two parts. This is the first part. So, first we're going to start out with a problem like this, where you have 17 to the 1/2 power, and you want to write it in radical form. Now, the exponent here is a rational exponent. Well, the way I always think of it is, suppose I have some number x, any real number x, and I have it raised to the p over r power, where p over r is the power divided by the root. So to write 17 to the 1/2 power as a radical, well, power of root, 17 to the first power, which is just 17, and then second root, so square root, because there's actually that little 2 right here. And then suppose I have another one that's a little more challenging, where it's xy raised to the negative 2/3 power. So I want to write this in radical form. Well, first off, it's a negative exponent. So I have to take the reciprocal of this, which would be 1 over xy raised to the 2/3 power on the bottom. Excuse me. So then to write it in radical form, well, power over root. These are both being raised to the second power. So I can just leave it like that, and then the third root. So put the little 3 there because it's a cubed root. Now we're going to get into, well, what happens when you have to start simplifying with rational exponents? Well, here's an example. Suppose I have negative 27 raised to the 2/3 power. Now again, power over root. Now, yeah, I could, now it doesn't matter the order you do it. I could take negative 27, square it, and then take the cubed root, or take the cubed root of negative 27 and square it. You're generally better off doing the root part first, because it makes it an easier calculation since you want to dealing with smaller numbers. So first off, the cubed root of negative 27, well, that's negative 3, because negative 3 times negative 3 times negative 3 is negative 27. So it's negative 3, I still have the power of 2 here. Well, negative 3 to the second power is 9. So that's the solution to this. So let's look at another one. Suppose I have 25 raised to the 3/2 power. Well, the square root, because power over root, the root is 2, or square root. So the square root of 25 is 5. The power is 3, so I got to do 5 to the 3rd power, which is times with 5 times itself 3 times, which winds up giving us 125. And then now if I have one involving a variable such that it's y to the 3rd raised to the 2/3 power. Well, just like when we take a variable and raise it to a power that's a whole number, we multiply them. Well, it's the same thing here, so now it's a fraction. So it's going to be y, and I do 3 times 2/3, which just gives me 2, so it's y to the 2nd. Now let's start going into simplifying radicals. So the square root of 2 times the square root of 32. Now, there's a few ways you can do ones like these. One way is, okay, I can just multiply them directly. So what I do is I multiply what's underneath the radicals, which is here 2 and 32. 2 times 32 is 64. But the radical stays, so it becomes the square root of 64, which is just 8. Or another way I can look at it is I can simplify the square roots first. Well, square root of 2, I can't do anything with that. That's as simplified as it can go. Now, square root of 32, well, let's see if we can break that down. So we want to try to find two numbers that multiply to 32, one of which is a perfect square. Okay, well, I know 16 times 2 is 32, and I know 16 is a perfect square. So I could write it as the square root of 2 times the square root of 16 times the square root of 2. And then I can keep breaking it down. Well, I know the square root of 16 is 4, and the square root of 2 times the square root of 2 is just the square root of 4. Square root of 4 is 2. 4 times 2 equals 8. So always keep that in mind. In math in general, you can solve a problem more than one way. Let me just clear the board here. Okay, so now let's go into something a little more challenging. Suppose I have the cubed root of negative x over 8. So what I can do is I can treat these separately, just like if it was a square root. So the cubed root of negative x over the cubed root of 8. Well, the cubed root of negative x, well, see, the cubed root of negative x, that's the same thing as saying the cubed root of negative 1 times x. So I could actually split that up into the cubed root of negative 1 times the cubed root of x, and then I just rewrite this. So the cubed root of negative 1, well, that's just negative 1. And then the cubed root of x, I can't simplify that further, so that stays as is. And then in the denominator, the cubed root of 8, well, that's a perfect cube, it's 2. So you wind up getting negative cubed root of x over 2. And there's another one where now we're going to have the cubed root of 3 over x times the cubed root, excuse me, 9 over x squared. So again, there's two ways you can solve these, just like with the square root ones, with the square root ones. You can deal with them separately and then multiply, or just multiply them directly. Now, in this case, you're better off just multiplying them. Why? Because 3 and x are not perfect cubes, and 9 and x squared are not perfect cubes. So we multiply them, just like with radicals. We multiply what's in the radicals. So 3 times 9 is 27, and x times x squared is x to the third. And the radical stays the same. It's a cubed root. Because just like before with square roots, we kept the square root, and now since it's cubed roots, we keep it cubed roots. So now we have the cubed root of 27 over x cubed. And now we can treat them separately, like this. The cubed root of 27 over the cubed root of x cubed. Well, the cubed root of 27, that's just going to be 3, and the cubed root of x cubed is just x. So the answer is 3 over x. Okay, now let's look at dealing with square roots. Well, suppose I have, or square root of an expression rather. Suppose I have the expression x squared plus 2x plus 1, and I want to simplify that. Okay, well, at a first glance, you would think, oh, I can't do anything with that. I can't simplify it. But we have to be sure. Well, this is a trinomial, a quadratic expression to be more particular underneath here. So the AC method, well, my A is 1, my B is 2, and my C is 1. So my AC value, well, that's just 1 times 1, which is 1. I have to find two numbers and multiply to 1 and add up to my B value, which is 2. Well, that's just 1 and 1. So that means this is going to wind up factoring to what? Well, I would have x squared plus x plus x plus 1. I rewrite it where now I have my middle terms written as 1 instead of 2x, it's x plus x. I split it up because 1 times 1 gives us 1, and 1 plus 1 gives us 2. Now we want to factor by grouping, so one group at a time. Well, out of this group here, I can factor out an x. And my factor out of x, I have x times, well, x plus 1. And then here I have x plus 1. Well, these are the same thing, but there's actually a 1 here, right? Because 1 times x plus 1, well, it's just x plus 1. And what do you wind up having here? Well, x plus 1 and x plus 1 multiplied. Like this. Or, the better way, since I have x plus 1 times x plus 1, well, it's going to be x plus 1 squared. Like this. I take the square root of it. These cancel out. I'm left with x plus 1. So that's the solution to that one. And clear the board again. Now suppose I want to combine radicals. Well, suppose it's 3 square root of 3 plus square root of 3. Well, think of this as 3x. Think of it as like 3x plus x. I have 3 x's here, I have an x here, I'm adding them. So 3x plus x, that gives me a total of 4x. Same thing here. There's actually a 1 here. So 3 radical 3 plus 1 radical 3. Well, 3 plus 1 is 4, and the square root of 3 stays the same. So that's going to do it for part 1. I hope this video helped, and I'll see you guys for part 2. See you next time. Bye-bye.